Right, question number 17, the last question in the paper, 17A. We're asked to show that the square root of 396 can be written as 6 lots of root 11, 6 root 11. This is a simplifying of surds question. You need to understand the rules in order to understand what you can do here. We've got a little bit of a clue with this 6, which is quite nice. So we don't really need a calculator to worry about what we need to do. But if you wanted to, you could ignore the surds. And if you did 396 and divide it by 11, you would get 36. Now, that's the number that you would get if you were to square this number in front of the 11 as well. So that's quite nice just to kind of think about. What we need to do is write down the square root of 396, and that equals the square root of 36 multiplied by the square root of 11. Now, we need to think about what are the factors of 36 other than 1 and 36, 2 and 18, etc. We've got 4 and 9. And 4 and 9 are both square numbers, and they're the ones we need to realise that we need to use in this question. So we can make this the square root of 36 becomes the square root of 4 multiplied by the square root of 9, and then we're going to multiply that by the square root of 11. Now these are square numbers, so they're not surds. Square root of 11 is a surd. These aren't surds. That's 2, and that's 3, and then that's root 11, and then 2 times 3 is 6. Lots of root 11, which is what we wanted to show it could be written as, and we have. The second part of the question asks us to, without a calculator, show that 4 plus 2 root 2 over 2 minus root 2 can be simplified to 6 plus 4 root 2, which all sounds very confusing and looks very confusing, but it's understanding the world of surds and rationalising the denominator. Now, to do that, I'm going to write down, first of all, the question, 4 plus 2 root 2 and over 2 minus root 2. To rationalise the denominator like this, and what we mean by rationalising the denominator is getting rid of the surd on the bottom, because a surd is a number that is irrational and it's not a whole number, so we can't have a whole number that's on the bottom of a fraction because it doesn't make mathematical sense. So we're going to rationalise it by multiplying by almost the same thing. We're going to multiply by 2 plus root 2. Now it's a plus because it's going to get rid of the surd when we multiply these two expressions together, and I'll show you that in a second. You have to multiply the top of the fraction by exactly the same thing like you always do in the world of maths. So I'm going to do that by thinking of these things as expressions. Effectively, the surds are the same sort of thing as x's unknowns if we were multiplying them together using our grid method. So I'm going to draw a grid with 4 boxes, and I'm going to put the terms of the expressions above. So I'm going to get 4, and do the top bit first. So 4 plus 2 root 2, and I'm going to multiply that by 2 root 2's, 2 plus root 2. And I'm going to multiply these things together. So I'm going to get 4 times 2, which is 8. 2 multiplied by 2 is 4, so plus 4, and I've got a root 2 there on the end, so stick that root 2 on there as well. 4 multiplied by 1, there's 1 root 2 here, is still 4. I'm going to get 4, and there's another root 2 on the end there. And then I'm going to do 2 multiplied by 1, so that is 2, and then root 2 multiplied by root 2 is 2, so I'm going to get 4 there. If you haven't understood this bit, I'll just write this out on the side. You've got 2 root 2 multiplied by root 2. 1 root 2 is there. Now the rules of surds say that you do 2 times the 1 and you get the 2, and the root 2 times the root 2 is 2. So you're going to get 2 times 2, and that equals 4. That's why this bit's 4. So 8 plus 4 gives me 12, and 4 root 2's plus 4 root 2's is 8 root 2's. So I'm going to write down plus 8 root 2's. That's the expression I've now got on the top of the fraction. Oops, I've covered over the 1 there. So 12 plus 8 root 2's. On the bottom, again, I need to draw myself a grid to multiply the expressions together. I've got 2 minus root 2, and I've got 2 plus root 2. 2 times 2 is 4, minus 2 root 2, minus 2 root 2, plus 2 root 2. Now, that's what I was talking about earlier about rationalising denominator. We're getting rid of the third element. If you've got 2 root 2's and you take away 2 root 2's, you've got no root 2's. So we've got nothing with thirds on the bottom, which is good. And then you're going to multiply these two things together, these two thirds. So root 2 times root 2 is 2, and one of them's negative, so it's going to be a negative 2. So all you've got in the bottom now is 4 minus 2, which is 2. And that's what you can put on the bottom of your fraction. So we're going to get 12 plus 8 root 2's divided by 2, which we can then show simplifies to what we want it to, because this term divides by 2 and this term divides by 2 to give you 6 plus 4 root 2's.